Speaker will be Jörg from, and we will start the slideshow. Who's the editor-in-chief of PLOS?
PLOS One.
PLOS One, sorry.
Thank you. Yeah, thank you very much. Yeah, I think we've come a long way. My first author paper was submitted on paper to Argonne, actually, a long time ago. It was the editorial office of Applied Physics Letters. Yeah, today I'm going to talk about how we can achieve reproducibility through some of the open science initiatives that we do at PLOS, in particular also PLOS One. Yeah, this is also following up from open access, because I believe open access allows everyone to access the research, obviously, and to read papers for free anywhere. And in my view, open science also allows everyone to do research built on the work of others in a way that goes beyond open access even. So it helps others to replicate, reproduce, which is the topic here, and build up on prior research output. So how can this be done? There's a couple of examples I'd like to show today. One is open data, and I've just presented in a session earlier, so it's going to be fast. We can help with opening up methods and protocols in papers. We can support preprints and also registered reports. So that's some of the initiatives that we are doing at PLOS. So open data is publishing, as you know, obviously, data underlying research findings. It needs to be fair, which means it's findable, accessible, interoperable, and reusable. So, I mean, these are the principles where sharing the data makes sense for others so that they can actually use it. Repositories obviously are key towards ensuring the fair data principles, as are the journals in applying the right policies. There also needs to be credit for authors, and this can be achieved through data citations, for example. So at PLOS we have a data policy, and I mentioned that earlier today. So all underlying findings described in a manuscript need to be available without restriction. There's some rare exceptions where patient privacy is concerned, or the location of rare species, for example. All authors need to provide a data availability statement when submitting to PLOS as a matter of policy. So since March 2014, when the policy came into effect, we've published about more than 96,000 papers with this policy. The uptake or the resistance from authors, at least those submitting to us, when we curate in some instances the lack of data sharing, only a very minor portion of authors rejected then the submission and the process at PLOS, and were not willing to share the data. There's still work to do. Only about 23% of that goes into repositories, which is like the preferred way of sharing data, because there you can achieve reproducibility. It goes into a location where you have the right kind of metadata, you have the right curation. You don't associate the data with the article, but you have the data as a piece of contribution to the scientific body itself, and it's citable and so on. So only about 23% of authors are doing this, but that's already an improvement from earlier, before our data policy is taking place, and the number is slowly going up. So there's an improvement on that front. The second item I would like to talk about is protocols and methods. So the experimental methods, protocols, or even what kind of reagents are used in experiments can be crucial towards reproducibility. Just using one supplier, changing supplier, may alter some of the results in a paper, or making the methods or the protocols in the wrong order, or in a slightly different way, again, may fundamentally alter the results that you are getting. So sharing protocols and methods is crucial towards reproducibility from our point of view, and even these kind of shared protocols, if they can be forked, which means can be built upon, copied, expanded, altered by others, and in a way that's communicated to the community, again, improves the reproducibility. And having this in one or a few selected places, again, it's the same as with data, makes it easier to find them, makes it easier to compare them, or to catalog them and structure them. So for that reason, since last year, we have a partnership with protocols.io, where we encourage our authors to also submit their papers to their protocols of their experiments to protocols.io. So they have a website, they have an app where you can, where then others can build on these protocols. So far, in the last year, close to 400 of these protocols have been submitted. And the way that it works is, if you can see that, on the left is the article in PLOS One, and it has like a data availability statement in the same way that we ask for this in the data sharing. And as part of the data availability statement, people can also link to the protocols.io deposited protocol. These protocols do get DOI numbers, they're persistent, and they can be cited and linked to. And then on the right is the protocols.io page, and it links back to the original article and has the protocol. And this one here is particularly nice example of that because they also deposit the code-to-code ocean. They deposit the methods, the protocol to protocols.io, and the protocol itself is actually quite detailed. It even has video examples of what they're doing in that particular study. So that shows you a lot of what can be done beyond just the paper itself in presenting research results. The next is preprints, and I think we've heard today as well in at least one other session about this, why they're important to establish priority, enable feedback early on for authors, allow credit before even the journal publication starts. I think there have been studies that show that papers that have been on preprint servers accumulate citations faster early on, at least, than papers that haven't. It combats publication bias because the results are published on the preprint server itself without knowledge of the ultimate journal that it's going to publish the paper. So it also changes a little bit the dynamics of the peer review process. So PLOS obviously encourages the use of preprints, and as of this month, authors submitting to PLOS journals have the option to have us post their manuscripts on bioRxiv. So what that means is that we do the usual vetting that bioRxiv does, and then push them for submitted papers that qualify, and push those papers as a preprint to bioRxiv if the authors agree to this. Obviously, they can still post somewhere else on a different preprint server instead, or they can just instead of also publish on bioRxiv themselves and then submit to us. But this is just another additional service that we provide. So the early uptake of this is around 20% of the qualifying submissions, which is an encouraging first start, given also that, at least for PLOS One, the scope of bioRxiv is much smaller than that, for example, of PLOS One itself. And then finally, I'd like to talk about registered reports, which is something else that we are supporting. So that is basically the peer review of the experimental methodology prior to the actual experiments being done. So for a registered report, the experiments that, or the study plan that researchers have is assessed by a journal with appropriate reviewers, statistics review, and so on, and they give feedback on the study plan. And that may lead to alterations of the study plan, but then at the end of the process, the journal provides an acceptance in principle, saying we will publish your study regardless of the outcome, whether the hypothesis that is tested in such an experiment is true or false, positive or negative, as long as the methodology is followed according to the plan. And so this combats the bias against negative results. It's in particular an unrelevant scheme, for example, in clinical sciences or in other areas where you are testing hypotheses rather than versus more exploratory research. So we have been working with a funder to trial this also at PLOS One. So we've been working with the Children's Tumor Foundation and one of their programs in neurofibromatosis, NF research. And the registered reports assessment at PLOS One is integrated in the funding process of that funder. So we issue this in principle acceptance where appropriate, and so far this year in the present funding round, it's just the first one where we've been trying this. 4 awards have been granted, and the interesting part that I like to emphasize is all 4 of them have seen revisions in this initial process. So it's not just that we look at it and say, yeah, that's fine for us, just do the work and come back to us once it's done. Our reviewers have suggested revisions to the experimental approach, and this should strengthen sort of the experiments that are being done and strengthen the outcome later of that work. So we will continue with this partnership, and I find the possibility of implementing registered reports exciting, because for those areas where it is relevant, it will definitely improve the reproducibility, it will combat publication bias, and will improve the research output. So finally, this is just the way that I see it, where there's similar to what Michael was saying, there's an entire ecosystem beyond the paper itself that is emerging. It's a preprints, it's a registered reports, it's open peer review, something I haven't mentioned here. It's the deposition of protocols, methods, computer code, other aspects of data, and the peer-reviewed manuscript is only one part of the ecosystem for researchers. Thank you.
Thank you. Thank you very much.